everyone, take a look at these videos. Their overall dynamic effects are notably stronger. The display of motion is also quite smooth. Furthermore, the generated videos include versions created from image to video as well as text to video. They include both landscape and portrait formats. Here, we will be using a new model called SmoothMix. What you are currently seeing is its address on Civet AI. Currently, this version has been upgraded to 2.0. Of course, the 2.0 version currently only exists for T2V, which is text to video. At the moment, downloading it still requires payment. However, in 12 days, you will be able to download the 2.0 version for free. Naturally, the 1.0 version is still free and available for anyone to download. There are some specific details introduced here. Let's quickly review them. It integrates a Lora into our WAN 2.2 model. This Lora was actually trained specifically for the WAN 2.2 model. The overall effect is quite good. Integrating it into our traditional WAN 2.2 model gives us the model we are discussing today. I have also built all the necessary workflows on Running Hub. You can access this platform by visiting runninghub.ai in the ComfyUI space. Running Hub is an excellent online workspace. This is because it immediately adopts any new technology or new models that emerge. You can register for Running Hub using the invitation link in my video description. This grants you 1,000 free points. Additionally, you will receive 100 bonus points every day you log into Running Hub. This allows you to try out your own workflows for free. Now, let's look at the specific usage of this model. First, we will examine the text-to-video version. I haven't made too many changes to this workflow. Please note that I am currently using the T2V 2.0 version, which is the paid version. This version can currently be used free of charge on Running Hub. Here we have the high noise model and the low noise model. In this specific workflow, we have removed all Lora models. This is because the model itself comes with an inherent acceleration mechanism. It already possesses the characteristics of an acceleration Lora, similar to what we call light X2V. Therefore, there is no need to use an acceleration Lora. Regarding other Lora models, we also recommend against using them. This stems from an explanation provided on the official website, which states that during testing, no Lora models were included, to ensure consistency in the results. They also suggest that we do not include any Lora. Next up are our text encoder and our VAE. In the section for defining prompts, I suggest that if you are working with an Oriental scene, you can use Chinese prompts. If the scene involves a Western figure, you should use English prompts. This generally leads to better character presentation. Also note that I use Sage Attention in the low noise model. For the high noise model, I used WAN video nag based on the actual situation. Not using these might not have a huge impact. Furthermore, in the sampling settings, it recommends 6 steps of sampling. The first 3 steps are dedicated to denoising the high noise model. The subsequent 3 steps are for denoising the low noise model. For the sampler algorithm, it suggests using UniPC. The scheduler algorithm should be set to simple. Alternatively, you can use Euler for the sampler algorithm, and the scheduler algorithm should still be set to simple. We previously tended to use LCM. However, that sampler algorithm did not perform exceptionally well in this workflow. Therefore, everyone should adhere to the official instructions when setting up the sampler. After decoding, you get the effect you see now. Let me first mention a drawback of this model. After integrating that Lora, this model seems to have removed many of the facial features typical of Oriental characters. Take a look at the scene I am showing. It is a classic Oriental flying Apsara setting. However, the character still retains Western features. On the positive side, observe that the motion effects are indeed richer, and the overall movement is smoother. Another consideration is the resolution setting. I am using 960 by 544 here. Our traditional setting method is typically 832 by 480. Because the sampling speed of this model is faster, I am able to set it to 960 by 544. Even if you set it to 1280 by 720, the entire process can still run. It just requires a longer sampling time. We have tested previously that if you use the base WAN 2.2 model, running 1280 by 720 might cause a VRAM overflow. The second example better demonstrates some of the model's characteristics, including its shortcomings. Please note that my frame rate setting is 16, not 24. Yet, you will still find that the movement is extremely intense. Therefore, this increase in dynamic effect can feel abrupt in certain contexts. It is not the case that this model performs outstandingly well in every scene. WAN 2.2 itself tends to be somewhat exaggerated in its motion rendering. After incorporating this model in certain scenes, like this one, you might find the action is a bit excessive. Our standard way of handling this is to add a frame interpolation model. Doing so might result in a better overall appearance. Furthermore, you should be aware that the resolution significantly impacts the result of the video generation. I am currently using 1280 by 720. If you change it to 832 by 480, you will notice that details such as the dragon scales and the armor's texture are not rendered as effectively. Therefore, everyone should try to increase the resolution. If you find the sampling speed slow at 1280 by 720, I believe 960 by 544 is a good alternative choice. This is a scene featuring a real person, a beautiful woman running through a wheat field. The display of the motion and the setting is indeed quite aesthetically pleasing, isn't it? This next one is a setup for a special scene. We intended for it to showcase the wind and the relentless flow of traffic. I still feel that its performance is a little overdone. Look at the feeling of the wind and the state of the cars. This shares the same drawback as the example we just looked at. So, when using this model, if this situation occurs, try to add a frame interpolation process afterward. We were just setting up landscape videos. I think the representation of portrait videos is much gentler. You will observe that the entire dynamic effect is concentrated on the waterfall. The character's movement, I think, is rendered quite normally and smoothly. That was the text-to-video model. You can download the image-to-video model here. Currently, this is only available in the 1.0 version. Let's examine some of the results from image to video. This workflow is also a traditional image to video workflow. I simply replaced the model with the SmoothMix we previously discussed. For resolution, we still suggest setting it to 960 by 540. Similarly, we change the sampling to 6 steps, and we adjust the sampler algorithm and scheduler algorithm to UniPC and Simple. There are no other major changes. For the prompt, you can leave it blank or include some general prompts. Here, I wrote best quantity and dynamic motion. Let's see if the dynamic performance is improved. This is a cover image I created previously. It is designed to show the interaction between a person and digital elements. Look, there are digital symbols here and a virtual screen. The character performs some actions. Let's see how it presents this content. I think this result is truly outstanding. I actually intended to depict an OCR process here, where content from a document is being extracted. Notice the character's movement and the data stream on the document. The display is quite breathtaking. The second image is one we have encountered before. This is a relatively magical scene, a person standing in a hall filled with playing cards, featuring very detailed lighting. Let's observe the generated result. You will notice that throughout the entire scene, every playing card exhibits a corresponding dynamic rotation effect. The character's walking movement is also excellent. It clearly conveys a feeling of languidness. However, I feel that the change in light and shadow is not particularly distinct. This is a scene of character interaction, two beautiful women touching fingertips. Let's see what kind of transformation follows. This looks very traditional, doesn't it? But I believe the dynamic effects are sufficient. This next scene features a character in an ancient tomb. Relatively speaking, the movement displayed in this source image is more intense. Let's look at the effect of the generated video. I think the presentation of the overall scene is also flawless. This includes the dust flying, the sparks splashing, the flame effects, and the person's movements. I believe it is an improvement over the native one 2.2. This is the model we introduced to you today. Overall, this model provides an enhancement in motion display. The sampling speed also sees a certain degree of improvement. Its shortcoming is that its overall rendering tends to be more westernized. If the video you plan to generate requires substantial dynamic effects, and you find that the traditional 2.2 model doesn't meet your requirements even after many attempts, then you might want to consider using this model. That concludes our session for today. Follow me to become an AI expert.